Hi everyone, welcome to the data structure tutorials. Today we are going to see queue data structure. Generally the term queue, what do you remember? We go to a movie theater and there is a ticket counter. In the ticket counter, what happens? There will be a board mentioning that follow queue. That means first person come and stand in queue, second person joins him, third person join. Similarly it goes. After he collects the ticket, who will be the first fellow to move out of the queue? The first person in the queue will be moving out. That means at the front. Rare, a new person will be added. After second person collect the ticket, he will be coming out of the queue. That means here two things that we are doing: inserting and deleting. How we are doing inserting and deleting? Insertion is happening at the rear end. Rear end means back side. Deleting is happening at the front side. Queue data structure also works on the same principle. Queue is a linear data structure that follows first in, first out. Whoever's enter into the queue first will be the person going out of the queue. Applications for the queue. Example, we all do printing the documents in a printer follows the queue data structure only. Consider you are having total 4 documents and first document has 20 pages, second document has 30 pages, third document has 40 pages, fourth document has 50 pages. And if you give print in the order, what happens is first document will be printed. While printing, you might have observed saying that documents for printing are in the queue. So the one who enters into the queue first will be the person or the document going out of the queue first. So under this principle, queue data structure works. This can be implemented by using arrays or linked list. Today we are going to see how to implement queues by using arrays. Now let us see the basic operation of queue. Let us consider this array. This array is of size 5 with the index 0, 1, 2, 3 and 4. If you want to insert an element into this array or delete an element in the array, let us follow the queue data structure. So when you are following the queue data structure, this array is an empty. So let us call this as queue hereafter. So this queue is empty. To indicate this queue as empty, we will be taking the support of two variables, that is rear and front. And these rear and front values are initialized with a negative number -1. Let us see why it is -1. Now inserting an element or adding an element into the queue is called as enqueuing, and deleting an element or removing an element from the queue is called dequeuing. If at all the queue is empty, rear and front values are -1. Similarly, if the queue is full, we will be taking the support of rear and front values. Let us see how it happens. The size of the total array is 4. Let us insert an element 1 into the queue. So the moment you insert, front and rear are is equal to -1 and -1 initially. After inserting, front will become 0 and rear also becomes 0. Now I'll be inserting or enqueuing an element into the queue. Now I'm enqueuing 2 into the queue. Now what happens? Front remains 0, rear is equal to 1. So that means we are incrementing rear by 1. Now I'm enqueuing one more element into the queue, that is 3. After enqueuing 3 into the queue, R value becomes 2. So here we are incrementing by 1. Similarly, 4 I am adding into the queue. Then R value becomes 3. I am enqueuing one more element 5. Here R value becomes 4. Here 4 is nothing but highest index of the array. If the size of the array is 5, if rear value is equal to size -1, that is 5 -1, 4, we say that it is full. And the condition for the empty is, we already know, rear is equal to -1, front is equal to -1, the queue is empty. If it is full, rear value becomes size -1. If that is the case, we can say this is full. Now how do we delete or how do you dequeue an element from the queue? The moment I am dequeuing, we will be dequeuing the element that is there in the front. Now front value gets updated to 1. So we are moving the front value. Next, Again we dequeue one more element, F value becomes 2. Again I'll dequeuing one more element, F value becomes 3. Again I dequeue one more element, 4. When F and R values are equal, it means that we are having only last element in the queue, and this is a linear queue. There are different types of queue. For those queues the condition may differ, but here the moment both the values are equal, if front value is equal to rear value and I am applying the dequeue operation, that means I am deleting the last one and only element that is there in the queue. So F value will become -1, R value also becomes -1. That indicates queue is empty. Let us see the operations insert and delete by taking a program. Consider this program. Design and implement a program in C to categorize the data. Consider the following sample list of numbers. Categorize and sort them into different groups as mentioned. Here, the question is very simple. You take an array that has the functionality of the queues. Here, you insert the elements in the form of queue. In the form of queue means 3 will be inserted the same way. 22, 12, 6. If I want to dequeue, which element will be removed? The element that is there in the front, and increment the front value to here. Now, what you have to do is, while adding the elements into the array, follow queues. And when you are displaying or when you are printing, you categorize these elements into 3 or 4 categories. First category, 3 and 6 are less than 10. So group these two numbers and print 3, 6. Here 12 comes between 10 and 19. So 12 prints here, and 22 comes between 20 and 29. So 22 prints here. And if at all, example, if you have 35, so 35 will be printed here, 30 and greater group. So this is how we need to design the program. Let us see and dive into what are the variables we require and how do we write the function. Let us implement code for the inserting elements in the queue. Now, let us understand what are these global variables. First, queue array. So queue array indicates the array. Capacity is nothing but the total size of the array. Here the index numbers are 1, 2, 3, 4. So the size of the array and the value to the capacity is 5. And rear is equal to 1, front is equal to 1. So we are taking two variables, front and rear, that helps us to insert and delete or enqueue or dequeue the elements from the array. Of course, we are utilizing this array in the form of queue. If rear is equal to capacity minus 1. So what is the capacity value? 5. 5 minus 1 is 4. Is rear is equal to 4? No. This condition failed. It means queue is not full. Right? Then else, come to the else part. Front is equal to minus 1. Front is equal to minus 1. So we are updating the value to 0. Front is equal to 0 we are doing. Enter the element which is to be inserted. So element, we have declared variable element of data type integer. Consider I am giving an element 25. So what is going to happen? Rear is equal to rear plus 1. Here we are incrementing the rear value from minus 1 to 0. That means minus 1 plus 1 is equal to 0. Q array of rear is equal to element. What is the rear value? 0. Q underscore array of rear value is 0. So we are updating the 0 to position the value by 25. Now consider we are calling insert method again. Now what happened? Again element a new variable will be created. Then rear is equal to capacity minus 1. So rear is equal to what? 0. Is 0 is equal to 4? No, the condition failed. Then it comes to if front is equal to minus 1, front is equal to 0. Is front is equal to minus 1? No, currently the front value is 0. Enter the element which need to be inserted. Consider I am entering the value 50. So now what happens? 50 will be updated here with the support of Q array rear, and by incrementing the rear value becomes 1. Q array of 1 is equal to element, where we are updating the value 50 here. Next, again if someone try to insert an element inside this array, we call this method insert element. Then rear is equal to capacity minus 1. What is the capacity value? 5. 5 minus 1 is 4. Is 1 is equal to 4? No, the condition failed. Then it comes to printf, it comes to the else part. In the else part, if friend is equal to -1, friend is not -1, then printf enter the element to be inserted. Consider user has entered the value 75. Now in the moment they entered the 75, rare value here is updated plus 1. So 1 plus 1 is 2. Now q array of 2, that means this position we are entering 75. After that, again if someone call the insert method, first a new variable element is created, rare is equal to capacity minus 1. So 2 is not equal to 4, the condition failed. Come to the else part, friend is equal to -1, no, friend is equal to 0. Enter the element that to be inserted. Consider user has entered element 5. Now rare is equal to rare plus 1, rare is equal to 2, so 2 plus 1, it is updated to 3. Q array of 3, we are inserting the element 5. Now after that, again someone has called the insert method. What happens? Again element variable will be created. Here rare is equal to capacity minus 1. Is 3 is equal to 4? No, the condition failed. Comes to the else part. If friend is equal to -1. Is friend is equal to -1? No, the condition failed. Here it will ask the user to enter the value. Consider I am entering 12. The moment I enter the 12, it goes to the next statement, that is rare is equal to rare plus 1, that is 3 plus 1 is 4. Now q array of 4 is equal to 12. 12 will be updated. Now consider again insert function is called. Element will be created. Yes, if rare is equal to capacity minus 1. What is capacity? 5. So 5 minus 1 is equal to 4. So rare has become equal to the capacity minus 1. That means q is full. Here what happens? Printf q is full and it does not execute anything in the else part, come out of the method. So this is how we are inserting the elements till it's full. So observe here, f value is 0, rare value is 4. Let us delete some elements from the array by using delete function. Deleting elements in the queue. The moment you call the delete function, default in the linear queue, what happens is the front element, front variable, whichever element it shows, that element will be deleted. Now let us try to understand how this function works here. Somebody has called the delete method. Now friend is equal to -1. Is friend is equal to -1? No, the condition failed. The once this condition failed, it comes to the else part. Element deleted from the queue is q array of friend. So q array of friend is 0, that is nothing but 25. So we are trying to show our print 25 is being deleted and friend is equal to friend plus 1. So friend is 0 plus 1 will comes to here. Now friend is showing this one. Next, when I call the delete function, what value it will delete? Whichever the value friend shows, that value will be deleted. Next, somebody has called the delete method again. If friend is equal to -1 or friend is greater than rare. What is friend value? 1. So which is not equal to -1, and there is one more condition. Friend greater than rare. Friend value is 1, rare value is 4. 1 is greater than 4. No, the condition failed. Comes to the else part. Next, element deleted from the queue. So which element we are deleting now? First element. Element array of friend. What is the friend value? 1. So 1 value is what? 50. So we are printing and showing it the user saying that 50 element is deleted. Friend is equal to friend plus 1. What is the friend value now? 1. 1 will be plus 1. It will come and show second element. Now already you know very well, when I call the delete method, which value it will delete? It will delete whichever the element that friend shows, that element will be deleted. Now somebody has called the delete method again. It comes to the if part. In if friend is equal to -1, is friend is equal to -1? No. Is 2 less than 4? Sorry, greater than 4? No. Condition failed. It comes to the else part. Print the element that it is going to print. So friend is 2. So q array of 2 is nothing but 75. 75 will be printed and shown to the user saying that 75 element is printed and 2 plus 1, 3. Now which element it is showing? Third element. Now what's going to happen? When you call delete method, third element is going to delete. So let us see how it works. Somebody has called the delete method. Now what is the friend value? 3. Is 3 is equal to -1? No. 3 greater than 4? No, condition failed. It comes to the else part. In the else part, what is happening? It is printing and showing to the user which element it is going to print. So it is going to print Q array of 3. So in the third position, when front value is equal to 3, which element is there? 5. So 5 is deleted. Then what we are doing? Front is equal to front plus 1. 3 will be updated to 4. Now what we are going to do? Front is equal to minus 1. Somebody has called the delete method. Front is equal to minus 1. Is front is equal to minus 1? No. Front is greater than rear. Is 4 greater than 4? No. Condition failed. Comes to the else part. Q array of front. So Q array of 4 is the front value 4. Q array of 4 is what? 12. So we are displaying to the user that 12 is being deleted. Front is equal to front plus 1. 4 plus 1 is 5. Now somebody has called delete method again because they don't know that whether Q is empty or not. We have deleted all the elements already. Now Q is empty. Now it comes, somebody has called the delete method again. When they call the delete method, it is coming and checking the condition. Is front is equal to minus 1. Is 5 is equal to minus 1? No, this condition not satisfied. We are using OR. So when you are using OR, either this has to be true or this has to be true. Here this is failed. Front, what is the front value? 5. 5 greater than 4. So condition is successful. This statement will be printed saying Q is empty. We cannot delete an element. Let us see how do we print the elements. So by this, what did you understand? Here there are two conditions. If front is equal to minus 1 or rear value is smaller than front or front value is greater than R, it means that Q is empty. Let us consider this array having elements 3, 12, 25, 10 and 33. So with the index values 0, 1, 2, 3 and 4. Let us try to display as per the question requirement. Let us trace this code. We call the display method. When you call the display method, we are taking an integer variable I. So I is the iterator. With this variable, we are going to traverse into this array and display the elements that are there in the array. Now, front is equal to minus 1 or front is greater than R. Here, front value is 0, rear value is 4. So these are the two variables that we are having here. With the support of these two values only, we are going to trace the complete array. If front is equal to minus 1, front is greater than rear, then it means that the array is empty or the Q is empty. But this condition failed. When Q is not empty, what we are going to do? We are going to print initially all the elements that are there in the array. So this is the for loop that it is going to help us to print. I is equal to front. I is equal to what? Front. Front is value is what? 0. And 0 less than or equal to 4. Condition is successful. Now what happens? Print Q array of I. What is the I? 0. So first it prints 3. Then it goes to I plus plus. 0 becomes 1. I is equal to 1. 1 is less than or equal to 4. Q array of 1. So what is there in 1 position? 12. 12 will be printed. I plus plus. Now 1 will become 1 plus 1. 1 will become 2. So 2 is less than or equal to 4. Now what happens? Array Q array of I. What is I value? 2. So what is there in the second index position? 25. 25 will be printed. 1 plus 2 plus 1. It becomes 3. So 3 less than or equal to 4. Now this condition also successful. Q array of I. What is I value? 3. In third position, what is the 10? 10 will be printed. Then 3 plus 1. So that is 4. I value becomes 4. 4 is less than or equal to 4. Condition is successful because 4 is equal to 4. Q array of I. I value is what? 4. So what is there in the fourth position? 33. 33 will be printed. Now 4 plus 1, that is 5. I value becomes 5. Now 5 is less than or equal to 4. Condition failed. It comes out of the for loop. I hope you understood how it is traversing the complete array and it is printing the elements 3, 12, 25, 10 and 33. Our goal is not printing the actual elements in the same way. Instead, we categorize the data. In what are the ways that we are categorizing? We are categorizing into 4 groups. Group 1 contains all the values that are less than 10. Group 2 contains the values that are between 10 and 19. Group 3 contains the values between 20 and 29. And group 4 contains the values that are greater than 30. Now let us try to trace. While tracing, what we are doing here, the same for loop we are doing, and we are tracing the array from first element to last element. Any element that occurs less than 10 we are printing here. Here there is one element, 3 will be printed. Next 10 to 19. So it must be greater than or equal to 10. It must be greater than or equal to 10 or less than 19. So first what happens? 0. Earth position 3 is there. 3 will not be printed. 12. 12 is greater than 10. So 12 will be printed. Then 25 will not print. 10. 10 is greater than or equal to 10. So 10 will be printed. 33 cannot be printed. Next group 3 is between 20 and 29. In between 20 and 29, that means value must be greater than or equal to 20 or less than 29. 3 cannot be printed. 12 cannot be printed. 25. Yes, 25 can be printed because 25 is greater than or equal to 20 and it is less than or equal to 29. So 25 will be printed here. Next, last and final element 33. So 33 is greater than or equal to 30. So what happens? 3 cannot be printed, 12 cannot be printed, 25 cannot be printed, 10 cannot be printed. So 33 is the number that is greater than 30 and that number will be printed. In the main function, we are using a switch case to choose different options. If the user select first option, it allows to insert an element into the queue. To delete an element in the queue, we will be calling or pressing the second option. And the third option is to display, and while displaying, it will be categorizing into 4 groups and showing. If you want to exit from the switch case, we can to press 0. Let us execute this program and see what will be the output. So the same program that we have seen till now is typed here and we'll be executing this program, and let us see the output. Here let's choose one option to insert an element into the queue. So let us enter 10 and one more value I am inserting 20, one more element 5, one more element 10, one more element 35, one more element 22, one more element 29. So these are the elements. Let us see the display of these elements by choosing the third option. So third option, it has shown 10, 20, 5, 10, 35, 22, 29, the elements that we have entered. Less than 10, 5 is the element that is less than 10, and 10 we have typed twice, so it is printing 10 and 10. The elements between 20 and 29 are 20, 22 and 29, and greater than 30 there is only one element, that is 35, that is entered. And let us call delete. So you all know that this is a queue. The moment you call the queue, what happens? The element that is there at the front will be deleted. Let us call delete method. The element deleted in the queue from the queue is 10. Then one more time. Now let us display. If you observe here, 2 elements are deleted. Now we are having only 5 elements in the queue.